Okay, so the sine ratio of angle A for the first triangle would be the opposite h over the hypotenuse, which is b. I don't mean to confuse you with using an h not on the hypotenuse, but I'm using h to represent the height, okay? Find the sine ratio for angle B. That is h over little a. And we're supposed to solve both of these for the variable h. So all I'm asking you to do is multiply by the b. So b sine of a will equal h. Okay, we're going to multiply both of these by a and get a sine of b is equal to h. Okay, so two separate triangles, but hopefully you see that they look like they're the same height. I did that on purpose. What we're getting ready to start today is something called the law of sines, and I want to show you where it comes from. I don't want to just give it to you. I want you to actually know where it comes from so you understand it. So if we were to slide these two triangles together, because they have the same height, okay, if we slid them together, we would get this big triangle right here. And so I kept my labeling the same. I've got angle A down here, angle B over here, side B, side A. Okay, notice they're directly across from the angles of the same letter. Okay, we created a new angle up here at the top. We'll call it angle C. So this entire side down here is side C. So up until now, the only thing that we've been allowed to apply trig to are right triangles. Okay, we've only been able to apply trig to right triangles. What we're going to look at today and over the next couple of days is how to be able to solve scalene triangles. A scalene triangle, if you've forgotten that vocabulary word, means no sides are the same and no right angles. Okay, a scalene triangle has no sides that are the same length, and there are no right angles. So we're going to be able to find the measure of all the angles and the sides of what we call a scalene triangle using trig, but here's why we can use the trig. Okay, so going straight off of what we just did, okay, since both of these, since h was equal to a sine of b, and h was equal to b sine of a, if they're both equal to h, then what can we do with them? They're equal to each other. So a sine of b is equal to b sine of a, and I would like my variables to be of the same letter to be on the same side. So I'm going to divide both sides by a little a. So I've got sine of big B. Okay, capital letters represent angles. Lowercase letters represent sides. Okay, and then I can also divide both sides by little b. So we end up with this ratio. The sine of big B over little b is equal to the sine of big A over little a. Now, I could do a similar thing and involve side C and angle C with this. I could draw a right angle originating from one of the other angles. I'm not going to go through that because it really does boil down to exactly the same thing here. But what you do need to know is this is the law of sines. The law of sines says that the sine of an angle divided by its corresponding side is equal to the sine of another angle divided by its corresponding side. Now, we're not going to end up with an equation that has two equal signs in it because that's not actually mathematically correct. But what you can do is you can pull out any two pairs that you need. Okay, I can do it with A and B, I can do it with B and C, or I can do it with A and C. It just depends on what information I'm given about the triangle. Will depend on which pairs I use. Okay, but the moral of the story is it's the sine of the angle divided by the side is equal to the sine of a different angle divided by its corresponding side. And it all comes from I can break this scaling triangle into two right triangles and apply trig to them. Okay? So let's use it. Okay? Here's case number one. If we have two angles and one side, we want to find the third angle and the other two sides. Now, it's not a right triangle, so we cannot use the Pythagorean theorem. I repeat, it is not a right triangle, so we cannot use the Pythagorean theorem. We have to rely upon the law of sines to be able to figure this out. So I've got a triangle set up just like the one that I had from the warm-up and that I used to show you where the law of sines comes from. It's not necessary, really, that you draw a picture every time, but I do know that some of you are more visual. So if you want a picture, draw a diagram. Okay, I have absolutely no problem with that. Some of you are fine with just plugging it into the equation. If you can do it, okay? So let's say that we are told angle C is 102 degrees. Angle B is 29 degrees. Side B, okay, it's always going to be directly opposite, is 28 feet. So that means we need to find angle A, and side C. What's the easiest of those to find? Angle A. We got two other three angles of a triangle. The fact that there are 180 degrees in a triangle has not changed. Okay, so all we have to do to find angle A is to subtract the two angles that we currently have from 180 degrees. So that part, easy peasy. Okay, 49 degrees, angle A is 49 degrees. Please do not leave off your degree symbol. Okay, need to always include units. Degrees are considered units. Okay, now to find the other two side lengths though, we do have to rely upon the law of sines. We cannot use right triangle trig. We can't set up the opposite and adjacent and hypotenuse because we don't have a hypotenuse because we don't have a right angle. Okay, so law of sines says that the sine of an angle, okay, I'm going to start with the angle inside that I know, the angle inside, I know both of them. So I'm going to start with B. So the sine of 29 degrees over 28 is equal to, I'm going to go with angle C next. Okay, the sine of 102 over side C. Now, if we're solving for C, what do? We got a fraction equal to a fraction. Cross multiply. Okay, cross multiply and then divide. So C sine of 29 degrees is equal to 28 sine of 102 degrees. I wait until the very end to put anything into my calculator. I'm going to completely isolate my side C before I start typing stuff into the calculator. So then I divide by the sine of 29. So C is equal to the exact would be 28 sine of 102 divided by the sine of 29. And no, those signs do not cancel. Okay, now here's what you got to make sure. We've been working in radian mode. Before you start typing stuff in, you better make sure you are in degree mode because you're getting ready to plug degrees into your trig function. That's why that mode matters. Okay, what you're doing is you're telling your calculator, hey, that number that followed that trig function is in radians, or hey, that number that followed that trig function is in degrees. That's why you have to change that. 28 sine 102. Close your parentheses. Okay, close your parentheses divided by the sine of 29. It is okay to just type this entire thing in. It will work just fine. So side C is approximately 56.493 feet. We had units in the original problem, so we need to put units in our answers. Okay, and I'm going to label this on my picture as well because I'm going to give you a little hint into a way that you can kind of check yourself after you finished it all. Okay, now to find side A, again, we're not allowed to use the Pythagorean theorem. It's not a right triangle, so we're just going to have to repeat the process of using our law of sines. I personally would go back to using the sine of B over side B because they gave me that information. As much as possible, I try to avoid using information that I have gotten as an answer, just in case I made a mistake in getting that answer. So I'm going to go back to what they gave me. This is going to be the exact same process here. A sine of 29 degrees is equal to 28 sine of 49 degrees. Divide by the sine of 29 degrees. So A is equal to 28 sine of 49 degrees divided by the sine of 29 degrees. This is what I want to see as your work if and when I give you a quiz on this, because if you're not in degree mode, but I don't know what you did to get to that point, if I can see that you have 28 sine of 49 degrees divided by the sine of 29 degrees, and you don't end up with 43.588, I'm going to know that it was probably because you forgot to make sure that your calculator was in degree mode. And I'm not going to count off as many points. If I don't see what you typed in, then I'm going to have to count off more because I have no idea where that number came from. Okay? So here's what I want you to always do before you move on with one of these problems. Hopefully you remember there's a property about triangles that says the shortest side is across from the smallest angle. The largest side is across from the largest angle, and then the one in the middle is the middle angle and the middle side. So check that really quick. Okay, our biggest angle is 102, so is 56 our biggest side? Yes, it is. Those are directly across from each other. 29 is our smallest angle. Is 28 our smallest side? Yes, it is. The other two, angle A and side A, are right in between. Well, not really in between, but they fit within the other two. Okay, so chances are we've done things correctly. Okay, it's just a quick, easy way to be able to check for a possible mistake. Okay, so practice